Welcome to homework questions from Chapter 1, 47 through 51. Question 47. Use your list of graph investigation questions from your learning log to answer questions about the graph shown at the right. And so the equation is y equals the absolute value of x plus 2, and then minus 1 on the outside. So you can see this shape of the graph, and you can see what's going on here. If you need to graph it on your graphing calculator to get a better view, you're more than welcome to. But I think the picture will do enough to help us describe it. So let's kind of go through and talk about the different things that are going on here. Remember, what kind of shape does it have? Well, this one has you might think it as a check mark, but remember this does continue on. So it's a V-shaped graph. It does open upward. A couple other things, look at some important points here. We have two x-intercepts at -1, 0 and -3, 0. We also have a y-intercept at 0, 1. We do have a minimum value at -1, which occurs at that special point called the vertex. We also know that it is symmetric across this line at x equals -2. And what else can we describe? As the x values increase, so as x increases, so as x gets larger, the y values decrease until it gets at that point x equals -2, and then they increase. So we do have the y values decreasing and then increasing. And so if there's anything else that you can think about, we kind of covered a lot there. So let me go ahead and type this out so you can see the different things that we just talked about. And so there I just kind of put it all together as to, once again, what the learning log is helping us describe this. The graph is V-shaped, opening upward. I labeled the x-intercepts, the y-intercept. Pay attention, they're ordered pairs, not just numbers. We have the vertex with a minimum value at y equals -1. There is no maximum value because the graph keeps increasing. It is symmetric. And as x increases, y decreases until at x equals -2. So right here at x equals -2, the graph is going down, the y value is decreasing, and then right there after x equals -2, it is increasing. Question 48. Calculate the value for each expression below. So in part A, the absolute value of -4 is 4, so 4 minus 3 is 1. For part B, the absolute value, and we have to simplify inside, so 6 minus 11 is -5. -5 plus 3 is -2, and then the absolute value of -2 is 2. Remember, don't do the absolute value until you've simplified everything inside. Part C, -9 minus the absolute value of -2, so that's -9 minus 2, which would then be -11. And then D, we have 5 times the absolute value of 6, or just 6, because 6 is 6 units away from 0. Multiplication first, so 30 minus 2. 30 minus 2 is 28. Question 49. Throughout this book, key problems have been selected as checkpoints. Each checkpoint problem is marked with an icon like the one at the right. These checkpoint problems are provided so that you can check to be sure you are building skills at the expected level. When you have trouble with checkpoint problems, refer to the review materials and practice problems that are available in the checkpoint materials section at the back of your book. This problem is a checkpoint for solving linear equations without parentheses. It will be referred to as checkpoint 1. So we're going to go through and solve all 4 of these. And we've been working on these throughout the first chapter. So 3x plus 1, or 3x plus 7 is equal to -x minus 1. So we want to get the variables on the same side, so we're going to add x. That's 4x plus 7 is equal to -1. Then we want to get the constant on the other side by using inverse operations. So we're going to subtract 7. And then we'll use inverse operations to undo the multiplication by using division and get x equals -2. B. It's similar, except now we have constants on the left side that can be combined. So I'm going to go ahead and combine those. That'll be -2x plus 6. It's a +5 and a +1. And then basically we're back to what we did on problem A. So I'm going to subtract the 4x. -6x plus 6 is equal to -3. Subtract the 6 to get the constant on the right. and then divide by negative 6. So 9 divided by negative 6 is, whoops, sorry about that, is 3/2 or 1.5. Alright, problem C. So same thing here, except now we can add our variable terms together. We can combine them. 4x plus 1, there's a 1 in front of that x, is 5x minus 2 is equal to negative 2 plus 2x. So I'm going to work with the variable term first. That'll give me 3x minus 2 is equal to negative 2. And I'm going to add 2 to both sides, and 3x is equal to 0. And then divide both sides by 3. 0 divided by 3 is 0. And then for problem D, I'm going to have to move this up a little bit so we can fit this on here down here. D, we have a couple things we can combine. On the left, we have negative 4 plus 1. So that is, what happened there? That is 3x minus 3 is equal to, and then on the right side, we have negative 2x plus 5x, so that's 3x. And then minus 5. So I work with the variable term first in most cases when I start setting things up. So I'm going to subtract 3x to both sides, and what happens on this one is that the variable term cancels out, and all we're left with is negative 3 is equal to negative 5, which is not a true statement, so that's not equal to. So therefore, there is no value of x that will ever work for this equation. So we will say that there is no solution to this equation. Now, it does say check your answers by referring to the checkpoint 1 materials. Also, ideally at this point, you are comfortable working with these types of problems and can solve them correctly. If you feel that you need more confidence when solving these types of problems, then review the checkpoint materials and try the practice problems provided. From this point on, you will be expected to do problems like these correctly and with confidence. So if you are working on these problems and you still don't feel confident in doing them, make sure you come in, get a little extra help, and these are going to continue to show up, so you just keep working on them and checking them. Question 50. Graph the points negative 3, 4, 1, 1. If you drew a line through the points, name 3 other points that would be on the line. How did you find them? Let's start by plotting the points. So here's your x-axis and your y-axis. Negative 3 is right here. Positive 4 is here. So we go left 3, up 4. And then 1, 1. You go over 1, up 1. So there's the point 1, 1. So now if we draw a line through the points, what are 3 other points? One way we can do this to make sure that we do it accurately is I notice that if I go down 3 and to the right 4, I hit that point. So I can kind of keep that pattern up, go down 3 and to the right 4. I can plot another point, down 3 to the right 4. And this just makes sure that I'm accurate in my points. Now I kind of ran out of room there, but I can go in the opposite direction. I can go up 3 and then to the left 4. And it'll still get me to a point on that line. So those are 3 points that we could use. One of them appears to be at negative 7, 7. That would be this one up here. The one down here looks at, let's see, that's 5, negative 2. And then the one over here is 9, negative 5. So those are 3 possible points. There's other points, obviously, that would fall on that line, but there's 3 of them that you could use. Question 51. Copy and complete each of the diamond problems below. The pattern using the diamond problems is shown at the right. So we continue to multiply to get the top number. So this is multiplication. And then to get the bottom number, we are going to add the x and the y if they're given. So on part A, the x and y are both given. So to get the top number, we're going to multiply 1/2 times 1/2. We can just multiply straight across, and that will be 1/4. And then so this is multiplication. And then for the addition, 1/2 plus 1/2, you do need a common denominator. You can add your numerators and keep your denominator the same. So 1/2 plus 1/2 would be 2/2 or 1. So then the bottom number would be 1. On part B, so we'll multiply 1/3 times 3/4. if we just multiply straight across, that's 3/12, but that can reduce to 1/4. So that's the multiplication. So once again, we're multiplying to get this number and adding to get that one. And so what is 1/3 plus 3/4? Well, we need a common denominator. So we're going to have to do a little bit of work here. Or you can just use your calculator. Multiply by 3 to the 3/4 and multiply top and bottom by 4 to the 1/3. That will create a common denominator of 12. And then now we can add the numerator, keep the denominator the same, and that would be 13/12 or 1 1/12. See if I can write that a little better there. 13/12. All right, now on to C. So now we're given just variables, x and x. Well, what is x times x? Now you could write that as your answer, but there is a way to simplify that. Since I'm multiplying a number times itself, I can rewrite it as an exponent. So that would be x squared. And then on the addition, what is 1x plus 1x? And that would be that there are 2 x's. So that would be the addition on the bottom. Same idea on D, except now the variables are not the same. So a times b is just ab. And then a plus b, since they're not like terms, we can't combine them. So that just means it's a plus b. So once again, continuing to work on the diamond problems, all of these were given the x and y values. So it was really just working on the multiplication and addition with fractions, and then C and D throwing in the variables.